Our AI agent tool use failure was boring until it cost a weekend. A support bot opened a Jira incident, the API timed out, and the loop assumed no confirmation means no ticket. It retried. Then Slack was noisy, so another watchdog saw 2 incidents and paged 2 different engineers. Both started fixing the same customer problem in different ways. The original write probably succeeded in under a second. The confirmation was the only thing missing. That distinction matters. In production loops, uncertainty is not failure, and retries are not free. The naive loop treats tools like function calls in a local program. Call create ticket. If the tool returns success, continue. If it errors or times out, call it again. That is fine for pure reads. It is dangerous for writes. GitHub issues, Jira tickets, Slack messages, emails, pull requests, and deploy commands change shared state outside the model. The remote system may complete the write and lose the response. The gateway may time out while the backend keeps working. The agent may only see an exception, then make the same write again. No confirmation is not did not happen. It is an unknown state, and unknown states need a protocol. The pattern is idempotent tool calls using an operation key and read act verify. Idempotent means you can repeat the operation without multiplying the effect. For agent loops, I do not rely on the tool magically supporting that. I design the call so the intended result has a stable identity. The operation key is project plus task plus intended result, not a random request ID the agent forgets. A meaningful key you can search later. Before writing, read, does this result already exist? If not, act once. After writing, verify by reading back. Success means exactly one matching object exists. 0 is unresolved. More than 1 is an incident. Put this in the tool contract, not just in the prompt. The contract should name preconditions, intended effect, verification, and write budget. A practical JSON shape is preconditions, intended effect, verification, and max write attempts set to 2. The first attempt is the normal write. The second is only allowed after a read says the intended result is still absent. Every write must return a receipt, tool name, operation key, timestamp, request payload hash, and any remote ID if available. Separate read tools from write tools in permissions. Many loops should read broadly, but write through a narrow, audited path. That split prevents a planning mistake from becoming a duplicate factory. Take a coding agent that files a GitHub issue when tests fail. The operation key is repository plus failing test name plus intended result. Track flaky checkout test. The agent first searches open and recently closed issues for that key in the title or body. If it finds exactly one, it attaches its evidence as a comment, only if that comment has its own key. If it finds none, it creates the issue and embeds the operation key in the body. Then it reads back using search, not memory, and requires exactly one match. If the create call times out, the next loop iteration starts with the same search. It does not blindly create another issue. This is not magic. Search indexes can lag, especially in ticketing and chat systems. That is why the second write attempt is a budgeted exception, not an infinite retry. Operation keys can collide if they are too vague, so include the project, the task, and the intended result, not just bug report. Humans can edit the created object and remove the key. Mitigate that with hidden metadata when the platform supports it, and visible metadata when it does not. The strongest rule is about duplicates. If verification finds 2 or more matching objects, escalate. Do not let the agent auto-delete one. It may delete the one with human discussion. This pattern sits right in the foundations tier because it touches every reliable loop primitive. Budgets matter because write attempts need a hard ceiling. State matters because receipts give the loop memory across retries and restarts. Verification matters because the agent should close the loop against the external system, not against its own last thought. Guardrails matter because write tools deserve stricter permissions than read tools. Later, at fleet scale, the same idea becomes distributed workflow safety, job IDs, dedupe tables, outbox patterns, and reconciliation workers. But the basic habit is the same. Name the effect, look for it, write carefully, verify it exists once. Here is the 10-minute exercise. Pick one automation that sends, creates, posts, or deploys something. Write down the intended effect in one sentence. Now define the operation key as project plus task plus intended result. Add a pre-flight read that searches for that key before any write. Add the key to the object you create: title, body, label, metadata, or footer. Add a post-write verification step that reads back and accepts exactly one match. Set max write attempts to 2. Finally, write the duplicate policy in plain language. If more than one exists, stop and escalate to a human. That one line prevents a lot of cleanup scripts. 3 beats to keep. First, a timeout is not proof the action failed. It is an unknown state, and unknown states require reads. Second, make every important write identifiable with an operation key: project, task, intended result. Third, close the loop by reading back and requiring exactly one matching object. 0 means unresolved. 2 means stop and escalate, never auto-delete. This is defensive engineering for AI agent tool use. Boring, explicit, and worth it. Episode 11 of Loop Engineering is done. New Loop Engineering episode daily on this channel, moving from foundations to fleet-scale agent operations.